Yan, no? So, welcome friends, no? So, today we will discuss the second topic on the applications of first order differential equations. Okay, this is known as the Newton's law of cooling. So, konting ano lang, no? Concept behind on how are we going to compute this kind of differential equations, no? So, Newton's law of cooling is, of course, it was proposed by Newton, no? Isaac Newton. Where when the time that he observed that the temperature, no, for example, okay, you are inside a room, no? Wala sa kwarto mo, no, nasa kwarto mo ka. Kunwari, ano ka, anak ka ni Daddy Pacquiao, meron kang dalawang aircon, no? Dalawang split type na aircon sa kwarto mo. Tapos nagpasok ka ng kape, kasi being a coffee person, no? Mahilig tayo sa kape. Nagpasok ka ng kape sa kwarto mo. Kung mapapansin mo, ang bilis lumamig ng kape mo from a certain temperature up to a certain temperature, another temperature. Diba? For example, bagong kulo yung tubig, diba? That's approximately nearly let's say mga 95 degrees Celsius, no? Kunwari, 95 degrees Celsius. Mabilis siyang bababa pag once na pinasok mo siya sa loob ng aircon. Kunwari sa loob ng kwarto. Kunwari ang temperature ng kwarto mo is let's say mga around 20 degrees, no? 20 degrees, malamig na 'yon. So, pagpasok mo, mainit pa yung kape mo, habang nagbabalorant ka, nakalimutan mo may kape ka. Mapapansin mo, pag chinek mo ulit, parang medyo bilis lumamig, no? So, that's one point of reference. Another one, nakalimutan mo ulit, no? Bumalik ka sa pagbabalorant mo, nakalimutan mo ulit yung kape mo. No, tapos pagka-check mo ulit, kung mapapansin mo, bakit parang hindi constant yung rate ng paglamig ng kape mo? Kasi from the moment na pinasok mo siya, for example, from 95 degrees, pagpasok mo sa kwarto after, let's say, after 5 minutes, kunwari, no, bumaba na into 60 degrees. Okay. Pero yung rate ng pagbaba from 90 degrees going to 60 degrees, is not the same as the rate of change from 60 degrees going to another lower temperature. No, yun yung sinasabi ng Newton's law of cooling. The rate of change of a temperature of an object is directly proportional to the temperature difference. Now, you need to take into consideration the word temperature difference between the object and its surrounding at a given instant of time. Okay, so how are we going to model this differential equation, no? So, sabi nga yung ating change in temperature denoted by capital T in respect to time, small t. Okay, this is directly proportional to the difference, no, nung object, ng temperature ng object, okay, denoted by T sub O, minus T sub S, which is the temperature of the surrounding. And if we're going to translate this one, no, into a differential equation, we will arrive with the dE, dt over dt is equal to negative K. Bakit siya negative K? Newton's law of cooling nga eh. Okay, ibig sabihin yung rate is decreasing, supposedly. No? So, negative K, T sub O minus T sub S. Where K is the cooling, let's say cooling coefficient. No, yung negative K natin is the cooling coefficient. Okay, so how are we going to solve this differential equation, no? So, just by using again, obviously this is variable separable. Okay. Varsep yan, guys, no? So, we have dt over t sub o minus t sub s is equal to negative k dt. Okay, so yan yung ating model differential equation. Then let's just get the antiderivative, no, of both sides. Itong T o minus TS, guys, just think of it as if it is just simply T, dt over T. Kasi 'di ba, remember, temperature difference nga yung hinahanap natin dito. 'Di ba? So ito yung meaning ng T sub O minus T sub S is the temperature difference. Not really the separate entity of the object's temperature and the surroundings temperature. Okay, so the integral of this is ln of T sub O minus T sub S. Okay, this is equivalent to negative KT plus C. Okay, so or gamitan na or yung ibang books kasi or katulad 'di ba sa temperature or yung ginagamit natin. So dito K na yung gamitin natin. Okay? So, by applying LNE property, di ba? So, this one will cancel. T sub O minus T sub S is equal to e raised to negative KT times e raised to C. Oops. Okay, where alam natin, no, ang e raised to C is just simply C. Diba? So, we're after the object's temperature, not really the surroundings temperature. Kasi hindi naman malaki or halos walang effect ang temperature ng object if it is greater or lesser than that surrounding. It is the surrounding that greatly affects the temperature of the object. Okay, so we have TO is equal to, transpose natin yung TS sa kabila, CE raised to negative KT plus TS. Okay, so this is the formula or the working formula kapag ang object daw ay being cooled. Meaning, TS, okay, TS is greater than TO. Okay, so yun yung ano, or simply cooling, no? Kapag ka ang tinatanong sa problem is cooling. Palitan natin, cooling. Yan. Sir, paano naman ang formula kapag heating? No, sa heating guys, okay, so since kapag heating guys, mas malamig, magiging mas mainit yung object or nearly lalapit yung paano ko ba explain? Sa cooling kasi, ganito na lang. Sa cooling kasi guys, no, from a high temperature, no, from a high temperature, bababa, okay, bababa to a lower temperature. Okay, yan yung ibig sabihin ng cooling basically. Surrounding has nothing to do with it pala. No, so pag heating guys, no, ang ating formula is T sub O is equal to T sub S minus CE raised to negative KT. Okay, this is for heating. Okay, kapag coming from a low temperature, you're going to arrive with the forward state of higher temperature. Okay, so yan yung mga working formulas natin, okay, for Newton's law of cooling. Okay, so let's try to solve. Okay, a KitKat bar with initial temperature of 37.8 degrees Celsius took 10 minutes to cool off to 32.2. So, hahanapin nyo na agad yung mga words na ganito, no? Just like this one, cool off. So, when you see the word cool, of course, it's cooling. Diba? It was found inside a room with 15.6 degrees Celsius temperature. How many more minutes will it take to cool down to 26.7 degrees Celsius? Okay, we already have our initial states, no? So we have here sulat ko muna, no? Ano yung working formula natin? This is T sub O is equal to, since cooling to guys, CE raised to negative KT minus plus TS tayo. Okay? So, yan yung ating working formula. So, ano yung mga hinahanap or kailangan natin? So, first we have T sub O at 0. Okay? So, this is the initial or TOI initial is equal to 37.8 degrees Celsius. Of course, ang time natin dito, okay, or ang TI natin dito is simply 0. No, hindi pa gumagalaw. Okay, it took 10 minutes to cool off to 32.2. So, T sub O, alitan sulat po. TO1, okay, this is the first reference, no? This is equal to, ano nga yung ano natin? 32.2 degrees Celsius. T sub 1, small t sub 1 is equal to 10 minutes. No? So, minutes naman yung tinatanong. So, kahit wag nyo na i-convert. Pero kapag tinatanong guys is hour, no? For example, ang given is minutes, then ang tinatanong is how many hours, you need to convert the time from minutes to hour. Okay? So, wag nyo kakalimutan yun. Okay? So, how many more minutes will it take to cool down to 26.7 degrees Celsius? TO sub 2 is equal to 26.7 degrees. Ano daw yung oras, no? How many more minutes? Okay, so by what we mean sa how many more minutes, diba hindi naman tinanong. Magkaiba kasi guys yung how many minutes will it take to cool down to 26.7 degrees sa how many more minutes. Okay, meron tayong word na more. Ano yung ibig sabihin na to? We need to take into consideration the first time na nag-cool down siya. Ano yon? Etong previous given natin. 10. Okay, so meaning T sub 2 is actually equivalent to T. Yun yung makukuha natin sa kung gaano katagal nag-cool down yung object, 26.7 degrees minus T sub 1. No, para makuha natin yung T sub 2. Okay, so let's try to solve. No, so we have here our working temperature, working formula. No, so we just need to first find what's the value of C. No, kasi yun yung usually yun yung una nating hinahanap kasi hindi naman yun usually given eh. So we have 37.8. By the way, I forgot what's the value of TS. That is 15.6, no? Hindi naman nagbabago. Sabi ko, hindi nagbabago yung surrounding, no? Hindi siya masyado nagbabago. Okay? So we have 37.8 is equal to CE raised to negative K times 0, no? That is T sub I plus 15.6. Okay, so we have this one is equivalent to simply 1, no? So we have C is equal to 37.8 minus 15.6. Okay, so this is the value of C. What's the value of C, no? So gamit tayo ng calcio, of course. Bring out ko lang yung calcio natin. Ayan. Okay, no? So we have 37.8 minus 15.6. Okay, so that is equivalent to 111 over 5 or 22.2. So sulat na lang natin dito. 22.2. No, so this is the value of C. Therefore, our new formula, no, working formula is T sub O is equal to 22.2 e raised to negative KT plus 15.6. Okay, so next, no, so we need to find the value of K, no, yung ating rate, no, yung gaano kabilis nag-change yung temperature from in an instant of time. Okay, so gagamitin na natin tong pangalawa. Okay? Gagamitin na natin to. So we'll have 32.2 is equal to 22.2 e raised to negative KT plus, or K times 10, diba? So, plus 15.6. Okay, so we'll have this, no? So, 32.2. Manipulate ko lang muna, no? Para mas madali. 32.2 minus 15.6. Obviously, that is 32.2 minus 15.6. Okay, that is 83 over 5, no? So, buray ko na lang. 8. Ilan to? Ayun, 16.6. No, buray ko na lang. So, we have 16.6 is equal to 22.2 e raised to negative 10k. Okay, so divide natin both sides by 22.2 kasi we are after the value of k, diba? So let me divided by 22.2, that's equivalent to 0.74, no? So, or basically 0.75. Okay, so 0.75 is equal to E raised to negative 10k. Okay, so ano yung gagawin natin dito, sir? Like the value of k, yes, no? So ano yung gagamitin natin na theorem or postulate to isolate the exponent negative 10k? No? So we're going to use ln property. Kasi 'di ba guys, remember sa ln property, 'di ba? If you have the natural logarithm of a certain number with an exponent, that exponent can be expressed as the numerical coefficient of the natural logarithm. So ilalagay natin 'to from the exponent papunta dito sa harap. Okay? Para ma-isolate natin yung variable na hinahanap natin. Then, ln e, kahit i-calculate nyo pa, ln e is equivalent to 1. Okay, so 1 times negative 10k is simply negative 10k. No, so, we'll have, dito ko na lang sa kabila, negative 10k is equal to the natural logarithm of 0.75. Then divide both sides by 10 kasi we're after negative k. Remember, negative k yung ating coefficient. Okay? Para hindi na rin kayo mahirapan mag-substitute. Baka mamaya kasi magkamali-mali pa kayo sa signs, no? So, 10 na lang yung iaano natin. Oh, ayan. Ay, sorry. So, we have negative k is equal to what? So, we have the natural logarithm of 0.75 over 10. This is equivalent to negative, no? Negative 0.028, no? Ayan, or 29. Kasi 7 pala yung susunod. Okay, so this is our negative k, no? So therefore, substituting the value of negative k, no, to the working formula earlier, ito yung nauna natin ginawa. T sub O is equal to 22.2. Sorry, baba ko lang yung calcu. Ayan. So, 22.2 e raised to negative 0.029 t. Diba? Plus 15.6. Okay? So, I hope you guys get it, ha? So, let's now find, no, gaano katagal ba nag-cool down yung object from 37 going to 26. Kasi yun nga yung point of reference natin. Unless magpapalit na naman tayo ng value na C, no, kapag nag-32.2 tayo. Okay? So, doon na tayo sa simula kasi ano na natin yun. So, again, ilan yun? 26.7. Sorry. Yeah. So, we have 26.7 is equal to 22.2 e raised to, sorry, e raised to negative 0.029 t, diba? Plus 15.6. So, we'll have 26.7 minus 15.6 all over 22.2. No, medyo sinorkat ko na lang ng kaunti, no? So, e raised to negative 0.029 t. Ayan. No, so, hindi nakakalimutan to guys, no? Ayan. So, paano tayo nag-arrive dito? So, this one is transposed to the other side. Okay, then after the transposition, dinivide ko lang all sides by 22.2. So, di ba ito may magiging negative 15.6 plus over 22.2. Cancel yung 22.2 dito. Diba? So, we'll arrive with e. No? E raised to 0.290. Ayan. Then, applying ln property, no? Para ma-scrape na natin yung ln e. So, we'll have negative 0.029 t is equal to the natural logarithm of, compute na natin, 26, oh sorry, para nakalabas ang calculate. Ayan, so we have 26.7 minus 15.6. Sorry. Ulit, 26.7 minus 15.6. Okay, divided by 22.2. Ayan. So, we have 0.5. Okay, so 0.5. Then, divide lang both sides by negative 0.029. Ayan. So, cancel na to. Also with this one. Okay. So, the value of t is just simply, okay, balik tayo kay calcu, the natural logarithm of 0.5 divided by, ano yung ano natin? 0.02. Yan. So, we have 23.9 negative, that's negative supposedly. Nakalimutan ko lang ilagay, no? Pero positive yung magiging sagot. Kasi, remember guys, a natural logarithm ng kahit anong value less than 1 but greater than 0 is negative. Okay, kasi ln0 is undefined. Okay, undefined na yung ln0. So, yung mga 0.00, 1.5, 0.75, mga ganon, laging negative ang natural logarithm nun. Since negative yun, negative divided by negative is positive. Okay, so, ulitin natin. 0.5, diba? Divided by negative, negative 0.029. Yan. 23.9 minutes, no? But is this our final answer? No? So, that's the big question. Teka. Baba ko lang yung calculate. Ayan, no? So, is this our final answer? Definitely, no. No, hindi pa. Kasi, di ba sabi nga, ano, t sub 2 is equal to t minus t sub 1. So, we need still to subtract 10. So, obviously, 23.9 minus 10. Okay, so, ang ating temperature, ang minutes na kailangan, no, is 13.9 minutes. This is our final answer. Okay, so I hope guys, no, naintindihan, chika naman siguro yan, no? So, basta as long as you know how to properly manipulate algebraically. Actually, it's more of algebra rather than calculus, eh. 'Di ba? So, kaya nga inintroduce ko na yung conversion nung differential equation, okay, earlier, kasi parang hindi na tayo magdi-DE dito sa part na to. We just need to analyze how are we going to use or implement that the equation that is solution to the differential equation. Okay? So, next, no? So, number 2. Suppose that an object initially having a temperature of 20 degrees Celsius is placed in a large temperature-controlled room of 80 degrees Celsius and 1 hour later, the temperature is 35 degrees Celsius. What will be the temperature after 3 hours? No? So, ito, na hindi naman na tinatanong 3 hours after the first increase. No? Ang sabi lang dito, after 3 hours. So, hindi siya katulad ng nauna na parang quote and quote merong more. Okay, so simply just after 3 hours. So, wala na tayong subtraction or addition na gagawin. Okay, so, since this is, how are we going to identify, no? Katulad nito, wala namang directly na sinabi kung heating or cooling. Check nyo yung initial, no? Initially, 20 degrees yung ating temperature. No? So, TO, ayan, TOI, or yung toy natin, no, that is 20 degrees Celsius, ang ating TO, or TI rather, is 0. No? So, from 20 degrees Celsius, sabi, no, after 1 hour, the temperature is 35. By the way, TS is 80 degrees Celsius. Okay? So, ang ating TO1 is 35 degrees Celsius after 1 hour. So, no need to convert to minutes, guys, kasi hours naman yung tinatanong. No? So, ang ating T1 is simply 1. No? So, what will be the temperature after 3 hours? So, ano daw yung TO2 natin after 3 hours? T2 is 3. Ayan. Okay, so, no? So, anong gagawin ko? Okay, so we need to identify, is it heating or is it cooling? No, so obviously 35 degrees is greater than the initial. Obviously this is heating. No, so for the heating, we have T sub O is equivalent to TS minus CE raised to negative 80. No, so lagi niyong tatandaan, ganyan ang formula kapag heating. Yung kanina kasi cooling. Okay, so let us identify what is C and what is K. Kasi 'di ba hindi naman binanggit kung ano yung rate, okay? So, let's solve for TS, no? So, we have, or rather TS, letter C po muna, no? Initial value. So, we have 20 is equal to 80 degrees minus C e raised to negative k times 0. Obviously, this one is just simply 1. No? So, therefore, C is equal to 80 minus 20. That is equivalent to 60. No? So, therefore, 60 ang value ng ating C. So, translating into the working formula, T sub O is equal to T sub S minus 60 e raised to negative 80. By the way, TS is 80. Later, papalitan na lang natin. Okay, what's the value of K? Ano yung gagamitin natin, no, to solve for the value of K? Of course, yung pangalawa. Okay, yung 35 degrees Celsius. So, we have 35 is equal to 80 minus 60. Ay, medyo naglalag. Wait lang. Saan ako? E raised to negative 80. Okay, so ano yung T natin? That is 1. No? So, negative K times 1 is negative K. Okay, just simply negative K. So, we have 35 minus 80. Okay, this is equivalent to negative 60. E raised to negative 80. Then, dividing both sides by negative 60. So, e raised to negative 80 is simply equivalent to, so, 35 minus 80, that's divided by negative 60. So, the answer is 3/4 or 0.75. 0.75. Okay, so, game, no? So, applying Ln property, no? To the whole equation, no? So, therefore, we'll have negative KT is equal, or negative K na lang pala, no? Kasi T is equal to 1. Negative K is equal to the natural logarithm of 0.75, which is equivalent to, so pakita ko na yung calcu, ha? Ayan. Ayan, so, the natural logarithm of 0.75 is negative 0.288. Yan. This is the value of negative K. No? So, baba ko ulit yung ating calcu. Okay. No? So, substituting to the working formula, no? So, we have our T sub O is equal to 80 minus 60 e raised to negative 0.288 T. No? So, sabi, no, ano yung tinatanong? How many, or what is the temperature after 3 hours? No? So, just substituting 3 to T, no, to small t, T sub O is equal to 80 minus 60 e raised to negative 0.288 times 3. Okay, so T sub O is equivalent to, balik yung ating calcu. Ayan. So, we have 80 minus 60. Shift ln para lumabas si e raised to negative 0.28, ano to, 288? 288 times 3. So, therefore, we have T sub O is equal to 54.71 degrees. Ano ba to? Celsius? Teka lang, kalimutan ko eh. Yeah, Celsius. No? So, degrees Celsius. And hindi rin naman tinatanong sa problem na mag-convert kayo, no? Pero kapag tinatanong, of course, you need to know the conversion. Okay, so T sub O is equal to 54.71 degrees Celsius. Okay, chicken ba guys? Chicken? Yes, yes, yes sir. No? So, okay. Game, no? So, third example. Okay, so number 3 tayo, no? So, water is heated to 80 degrees Celsius for 10 minutes. No, sabi dito. How much would be the temperature in Kelvin Okay, if R is equal to 0.56 per minute and the surrounding temperature is 25 degrees Celsius. Okay, so medyo tricky to in the sense na baka una nyong isipin, okay, heating. Kasi guys, di ba, oo nga naman, meron tayong word na heated. Okay, however, that is the condition before we model the differential equation. Okay, so magiging initial natin dito, okay, at time 0, the temperature of the water is 80 degrees. Pabaligtad yung analysis nito. Okay, so at time 0, ang ating T sub O is 80 degrees Celsius. Okay, so rate is, or yung K natin, is 0.56. Okay, TS, by the way, is 25 degrees Celsius. Sabi, no, what is the temperature at T is equal to 10 minutes after the heating occurred. Okay? So, yun yung tinatanong. After the heating occurred. So, meaning, wala nang supply of heat doon sa system natin. Magko-cool down ngayon yung system natin. Okay? So, this is cooling. No, hindi siya heating. So, we have, therefore, since cooling to, no, T sub O is equal to negative, negative tuloy. CE raised to negative KT plus T sub S. Okay, so let's solve for the value of C, no, yung initial natin. Okay, sabi at time 0, ano daw yung value ng T sub O natin? That is 80 is equal to CE raised to negative 0.56 times 0, okay, plus 25 degrees Celsius. Excuse me. No, so cancel, no? So this will just be 1. C is equal to 80 minus 25. So this is equivalent to 55. Okay, so going back to the model, no, so we have T sub O is equal to 55 e raised to negative 80 or negative 0.56t, okay, plus 25 degrees Celsius. Okay, so this is our T sub O. Okay, so let's compute, no? Ano daw yung T sub O after 10 minutes, no? So we have 55 e raised to negative 0.56 Ayan. Times 10 plus 25. Okay, so ang ating T sub O ngayon is equivalent to, okay, balik ko lang yung calcu. Ayan. So we have 55 e raised to negative 0.56 times 10. Okay? Plus 25. Ayan. So therefore, that the temperature after 10 minutes, no, nung matapos iinit, no, is 25 degrees Celsius, no. So that is 25.2 degrees Celsius. However, the question na tinatanong, what is the temperature in Kelvin? Okay, so we need to convert the temperature from degree to Kelvin. And to do that, we're just going to add 273. No, so therefore, add ko lang, no, diretso na, 273. So this is equivalent to T sub O is equal to 298.2 Kelvin. No? So this is our answer. Okay? So baba ko lang yung calcu. Ayan. No? So this is our answer. Okay? So malamig na ba yung ininit mong tubig after 10 minutes? Definitely yes, no? So malamig na 'yon after mo siya iinit. Okay? So yan. Number 4 tayo. No, sabi dito, a thermometer reading 75 degrees Fahrenheit is taken out where the temperature is 20 degrees Fahrenheit. The thermometer then read 30 degrees Fahrenheit 4 minutes later. Find the time in minutes taken for the reading to drop from 0.75 degrees Fahrenheit to within half degree of the air temperature. So, kailangan magaling kayo mag-analyze ng wordings talaga dito, no, sa applications of FODE natin. Okay, so sabi dito, okay, thermometer reading 75 degrees Celsius, okay, so wala naman sinabi na kung after ilang minutes, okay, meron pa nga, present tense is, no, so meaning this is the initial temperature, no, so T sub O, palit ako yung kulay, is equal to 75 degrees Celsius. Degrees Fahrenheit pala, sorry. Okay, so the thermometer then read, okay, so T sub S by the way, a time is equal to 0. T sub S is 20 degrees Fahrenheit. Okay, sabi after 4 minutes, no, so T sub O na daw is 30 degrees Fahrenheit after 4 minutes. Okay, so sabi, ano daw yung time, no, ano daw yung T, kapag yung TO daw is nag-drop, no, from 0.75 to within half degree. Ano yung tinutukoy sa within half degree? No, so, technically, half degree is 0.5. Okay, then, pag may nabasa kayong within, i-add nyo lang siya dun sa base, excuse me, i-add nyo lang siya doon sa base quantity, which is the air temperature. Ano ba yung air temperature? Yung surroundings. Okay? So, T sub O is equal to 20.5 degrees Fahrenheit. Okay? So, as simple as that. Okay? So, we have T sub S. So, definitely this is cooling. T sub O is equal to CE raised to negative KT plus T sub S. Okay? So, we have 75 is equal to CE raised to negative K times 0. Obviously, this is 1. Diba? Plus 20 degrees Fahrenheit. Ayan. No, so, C is equal to 75 minus 20. This is equivalent to 55 degrees Fahrenheit. Okay? 25 degrees lang pala rather. Sorry. Okay, so, E sub O is equal to 55. E raised to negative KT plus 20. Hindi pa natin alam yung K, so we need another set of values to get the value of K. No? So, ano yung susunod natin? Ito na. No, yung 30 degrees when T is equal to 4. So, 30 is equal to 55 E raised to negative K times 4 plus 20. Okay, so 30 minus 20 over 55 is equal to E raised to negative K times 4. Diba? So, applying natural logarithm exponential property, ln E property, no? So, we will have, cancel na to, negative K times 4 is equal to the natural logarithm of 10 over 55. Hindi ko ginamitan ng calcu ha. Ayan. So, divide both sides by 4. Remember, negative K na yung kukunin natin. Okay, so, kapag ganito yung problem, so we have negative K is equal to the natural logarithm. Okay, ito na, gagamit na ako ng calcu. Hindi na to kaya ng mental powers ko. No, so, we have, ayan. So, ayan, the natural logarithm of 10 over 55 divided by 4 is negative 0.426. Okay na to, no? 3 decimal places, no? So, or kung gusto ninyo, which I actually highly suggest, store nyo, no, sa A. No, para at least later yung negative K nyo, yung A na yung gagamitin mo. Okay, so baba ko muna yung calcu. So, our working formula now, T sub O is equal to, ano yung sinangan natin? 55 E raised to negative 0.426T plus, ano yung ano natin? 20. Okay, so what's the temperature daw, no? Or ano ba tinatanong? Teka. Time pala, no? Hindi pala yung temperature. What's the time, no, needed to drop the temperature from 75 to 20.5, no? So, ayan. So, 20.5. Wait lang, medyo naglalag. Ayan. 20.5 minus 20 all over 55. Tapos, since e raised to negative 4.26, no, ln na ilalagay natin dito. Then, divide natin buo by, sorry, naglalag, by negative 0.426. This is equal to t. Ayan. Okay, so just plain algebra. No, so, with konting ln e property. Ayan, no, so, computing, no, for t is equal to, uso ko lang. Labas ulit natin yung calcu. Ayan, no, so for this, we have the natural logarithm of 20.5 minus 20, of course, that is 0.5, over 55, divided by, diba, in-store natin sa A yung ating answer. Ayan. So, we have t is equal to approximately 11.03 minutes, no? 11.029 minutes pala. Ba ko lang yung calculate. Minutes. Ayan. Okay. No? So, that's it, no? So, that is the Newton's law of cooling modeling ng ating differential equations. I hope you guys learned something, no? So, next meeting, next topic, we'll discuss Newton's second law of motion, no, which is law of inertia, and how differential equations is applied in physics of forces. Okay, so thank you for listening. Stay safe and God bless.